Hello again. This is Mr. Ford, and today we're going to be doing double by double digit multiplication. I'm going to be showing you three different methods for doing double by double digit multiplication, or multiplication where both factors are in the tens place value. We're going to be breaking some numbers apart. We're going to be doing some traditional vertical multiplication, and we're going to be doing some lattice multiplication. So let's start over here. So for this method, we have some horizontally placed questions, and I'm going to be just breaking them apart. Now, I'm going to be going through the process that I would normally go through in my head. So one of the ways that we can think about this problem is that both of these factors, 17 and 32, they're actually a combination of some smaller numbers that we're a bit more comfortable with. So what we're going to do is we're going to pick a factor to break apart. I'm going to break apart 17 because it's smaller. I'm going to break it into 10, and I'm going to break it into 7. So I know that 10 multiplied by 32, well, anything multiplied by 10 increases that other factor by a factor of 10. We add one place value, so I know that this quite easily is 320. Now this second problem here, this one you might find a little bit harder. So what I'm actually going to do, instead of counting 7 groups of 32 or 32 groups of 7, in which the potential for me making an error increases, I'm actually going to break 32 apart. So I'm going to break this into 30 and 2, and I know that 7 multiplied by 10 is 70. I know that 3 groups of 70 is 210. And I know, well, 7 multiplied by 2 is 14. Then I add those two together. And we have 224. So now I have these two separate products, and just like we did with double by single digit multiplication, I'm going to add those two together. And we're left with a product of 544. So that's one way that we can break a larger multiplication problem into friendly factors. We'll do one more of those problems. I'm going to highlight our last problem in pink for you, so our page doesn't get too confusing. This new problem, 58 multiplied by 82. These are much, much larger numbers, but that's okay. What we're going to do, same thing as we did last time, we're going to break this apart. Now notice, I'm not breaking them into 8 and 2. That's because this isn't an 8. This is 80. Right? This 2 is here, and it's in the ones column. But this 8 here is in the tens column. So it doesn't represent 8, it's representing 80. Same thing with this 5 over here. This isn't representing 5, this is representing 50 for 59. So when we break these apart, it can't be 5 and 9 or 8 and 2. It needs to be 50 and 9 or 80 and 2. So keep that in mind when you're doing this. So we're going to 50 and 9. Well, 50 multiplied by 82, that still seems pretty difficult. So we'll have to do something about that. 9 by 82, however, that seems a little bit easier. Well, let's go back up here and let's deal with this first. So right now we've got 50 multiplied by 82. Well, that's still really big. But we can break 50 down even more into 5 tens. Giving away the answer here. And I know that each time we multiply that, it just increases by a factor of 10, so we get 5 820s. And instead of stacking all of these on top of each other, I'm going to make my life a little bit easier. I'm going to add 820 to 820. I'm going to cross these two out because I added them together. I know that if I do the same thing with these two, I'm also going to get that. And so instead of adding again, because I know that I'm going to get the same sum, I'm just going to put that here, cross those two out, add this together. And then lastly, add that last 820. So I know that 50 multiplied by 82 gets me 4,100. 9 multiplied by 82, well, I can break that 82 apart. Do 9 multiplied by 80, 9 multiplied by 2. Well, 9 multiplied by 8 is 72, and we're just increasing it by a factor of 10, so I have 720. And 18 added together. And these three numbers I need to add together now. So this comes to 738. Add 4,100. Make sure my place values are lined up correctly. So I know that the sum, or sorry, not the sum, the product of the two factors, 58 multiplied by 82, is 4,838 by breaking these into friendly factors. But again, when you get into these larger numbers, this starts to get a little complicated. If you maybe forgot to add one of these 820s when we broke apart the 50, or maybe you tried to do it as 50 multiplied by 82 and you were off by 100 or 200, that could completely change the product that you end up with. So while this is a good strategy to use, and this can be helpful as a mental math strategy, it does take up quite a lot of space, and the number of steps, as your number of steps increases, so does the chance of you making an error. So let's try some options that have a few lesser steps. Traditional multiplication. So we're going to start off, as always, with the smallest place value of our multiplier multiplied by the smallest place value of our multiplicand. So our ones by our ones. So we have 7 multiplied by 6, which is 48. We regroup our 4 because, again, it represents a 40. Now, most of the time, an error that occurs when people are doing this is they think that this is just like an addition problem. So, I did my ones by my ones, now I do my tens by my tens, and I'm done. But that's not the case, because this is multiplication, this is not addition. So while they look similar, our next step is actually going to be diagonally multiplying 8 by 5, which is 40. 40 add 4 equals 44. So we add our regrouped 4, and we get 44. Now we've finished with our ones place. So we have to multiply our 7 by 56. But this isn't a 7. This is 70. It's in the tens column, right? This is the ones. This is the tens. All right, so if we were to remove that 8, which we've done now by multiplying 8 by 56, we're left with 70. So we need to put a 0 here to remind us that, hey, this isn't a 7, this is 70. So we're going to multiply diagonally to start. We're not just going to go up to the 5, we need to multiply by the 6. So 7 multiplied by 6 is 42. Again, we regroup that 4. I'm going to cross out the last 4 so I don't make the mistake. If you get comfortable with the idea of, oh, well, the tens number that I'm regrouping is the same as the last number I regrouped, I'm just going to put it up there, you could forget and easily go, oh, well, I already added that one, so I don't have to worry about it. So I'm going to cross that old 4 out, put a new 4. Now I've done 7 multiplied by 6. I'm going to do 7 multiplied by 5. That's 35. 35. Add 4. It's 39. And I'm left with 2 products. Essentially what we've done is we've multiplied 56 by 8, and we've multiplied 56 by 70. So just like in the last couple of steps, we've broken apart one of our factors to multiply, but this way, the traditional multiplication method keeps things kind of nice and neat in a small area, whereas you saw on our last problems, they kind of started getting away from us. They were getting really big. We were having to break numbers down multiple times, and it was just very confusing. This is a much simpler way of doing that. So now we have our 2 products. We're going to add those together. I regroup a 1 because I know 9 and 4 are 13. And we're left with a product of 4,368. You can see that we have taken up far less space than those other 2 problems. And arguably, the number we're using over here, 56 multiplied by 78, is roughly the same size in groupings. Even our product is similar in size. So you can see this takes up far less space. We're going to do this one now. We're going to do 37 multiplied by 48. And we're going to start off with the same process. 7 multiplied by 8, 56. We're going to regroup our 5. We're going to go diagonal. 8 multiplied by 3 is 24. 24, add 5, equals 29. We're going to cross out that regroup number. Now we're going to go to 4. Again, this isn't a 4, it's a 40. It's in the 10 spot, so we're going to put a 0. Diagonally to start, 4 multiplied by 7 is 28. Regroup a 2. 4 multiplied by 3 is 12. 12, add 2 is 14. Now we have our 2 products. Our products from multiplying 37 by 8 and 40 by 37. We're going to add those together. And we end up with a product of 1,776. Lastly, we're going to complete 2 double by double digit operations using lattice method. So the first one we have is 97 multiplied by 76, reading left to right and top to bottom for each number. We're going to start with the smallest place value, so out of 76, that's 6. 6 is in the ones. 6 multiplied by 7 is 42. 6 multiplied by 9 is 54. 7 multiplied by 7 is 49. 7 multiplied by 9 is 63. We're going to add up all of our numbers in their diagonal columns to get our product. 9, add 4 is 13, add 4 is 17, 1 and 4 is 5, 8, 13, 6 and 1, 7. And we're left with a product of 7,372. Last lattice problem and the last double by double digit problem we're going to do here today. 63 multiplied by 29. 9 multiplied by 3 is 27. 9 multiplied by 6 is 54. 2 multiplied by 3 is 6. 2 multiplied by 6 is 12. Same thing again, we're going to add them all together. Regroup. 1 and 0 is 1, 3, 8, and 1 is by itself. And we're left with a product of 1,827. So you can see there's a lot of different ways that you can multiply double by double digit numbers. What's important is that you should be confident in at least one of these strategies. You can use elements from either strategy, and you do need to have a very good understanding of your basic multiples, your multiples where the factors are between 1 and 12. And once you have a good, solid understanding of those, then this becomes really easy because you're just following steps. If you get really comfortable with the traditional multiplication, then do that for all the multiplication operations that you're asked to do. If lattice is your thing and you like being able to see all the different numbers broken apart, then do that. Right? If you're somebody who you get to a point and you need to break that number apart, that's fine. Keep in mind that it can get really messy, so you need to come up with a system on your own of how you're going to order it. Again, this has been Mr. Ford, and we have been looking at double by double digit multiplication.